Welcome to the N1IR Electronics Blog, video number 6. PCB design, old school method. Okay, I've been asked quite a bit of times how do I design out PC boards, and you know, a lot of people design it out in CAD, but if you're at home or if you don't have a computer, or if you just don't have the resources available for PC board design software, you can still design your own PC boards out. And I'm going to start off with this circuit right here. This is one circuit that my buddy asked me to produce. Basically, it's just a 555 flasher circuit. The values aren't important right now for the PC board design, but what is important is you actually get the physical components. So I got the 555, the LED, the resistors, the capacitors, etc. So this is for your pin spacing and stuff like that, so you want to be able to measure that. So let's put those off to the side. So here is our schematic here, a typical astable LM555 circuit. So one of the first steps what I do is I cut out a piece of copper. This normal piece of copper, single-sided. You can fit this into your enclosure or whatever. This is just a piece of scrap that I had hanging around, so I made it so I can make it large enough for you guys to see it. So the first step is just trace out your board. There you go. And you're going to need a couple other materials too. You're going to need a PCB design template, something like this. This is a made by Pickett. It's a PCB design template number 1616I. And if you're doing schematics and stuff like that, you don't have a schematic capture program, you can still do all your stuff out in paper. This is an old template. This is from Rapid Design number 316. It's actually Missile and Space Electronics. You know, these were made back in the 60s and 70s and stuff like that. They're still available today. They're pretty expensive though, like $8-10 a shot. So, okay, back to the PC board design. So what I like to do is, if I'm just using one chip, I like to lay out the chips first, right dab in the middle. So we have a 8-pin chip. So I have a little bit of graph paper here. I don't know if you can see it or not, the lines. Also the template has these little spaces in them. I don't like to use that. I like to go on the opposite end so it's flat against the paper. So here's our center right about here. I put a light line so I can see it. And I want to put down my pads for the IC. So it's going to do every other one. That's pin 1, pin 2, pin 3. Come down one like that. Okay, so the method we're going to do is we're going to design our PC board as a top view. And then what we're going to do is we're going to get a light box and retrace that so we flip it over so you have the copper view. What I like to do too, another little trick, is that you make just a light line on the top and the bottom, and this is where my proposed bus line is going to come in for my power. I'm going to have minus up here and plus down here. Now this is just temporary, just to kind of define where my power pins are first. I like to do that first. So here's pin 1. So mark that with a little 1. So it goes 1, 2, 3, 4, 5, 6, 7, 8. So pin 1, I'll connect up to minus. This is all light right now. Light traces. There's nothing set in stone. So I'm going to darken up these guys a little bit. Okay, the next one I'm going to have is 4 and 8 going up the plus. So you can go right underneath the chip here, connect these two pads. Now it's pretty funny, when you get enough experience, like I do, I can usually beat the CAD guys. Okay, so I'm going to make that plus. You notice I put plus down here. I'm not going to go with that. I'm going to go with plus up top. That's just from experience. And the best way to do this is practice. I guarantee you'll make mistakes and figure them out as you go. But that's okay if you're doing your own designs, and it doesn't matter. Okay, so let's refer back to our schematic. Now another trick is I can take a highlighter and highlight the connections I've made. So I've connected pin 1, 4, and 8, so I could highlight that with a highlighter. That's another little trick that I've developed over the years for more complex circuits, but this is pretty simple. I'm going to skip the highlighting right now. But 4 and 8 go up the plus. Excuse me. And 1 goes to ground. Okay, now we want, let's see if I can get both in here in the camera. Now we want this resistor. This goes from 7 to plus rail. So the resistors I'm using is a typical 1/4 watt through-hole resistor. So in our design template, we have one for a 1/4 watt. So I'm going to line that up with pin 7. Okay, so there's our resistor there. So I can move this trace down a little bit. I can thicken these up later too. Typically I also use Sharpie markers when I do this. Another handy thing to have is a ruler. And if you have one, a copy machine. That makes things a lot easier. So you can make multiple copies and just, do some revisions and stuff like that as you go. It makes the work a lot easier if you have a copy machine. I was doing this PC board design work back in the 80s when copy machines were kind of a luxury, so that's always a nice thing to have, is a nice little copy machine or scanner or something. So now we have we'll go back to our schematic. We have pin 7 going up through our resistor to plus rail. We also have a resistor going between 7, 6, and 2. 6 and 2 are connected together, so I can put another resistor, and I'm going to place that guy right about here. Now notice I can go under the components too. That's perfectly okay. So bring this trace underneath, and when I see this through the light box, I'm just going to trace out the traces and not the component outlay. The component outlay is really for the top layer. And this is where your copy machine comes into place. I can copy this as it's done, and then erase all my traces and do a component overlay, and flip it over and do my traces and stuff like that. So a copy machine comes in handy. Then you don't have to do it over and over again by hand. But if you don't have anything like that, like I do here at the shop, you can certainly do it all by hand. It just takes you a little bit longer. Okay, so there's pin 6. 1, 2, 3, 4, 5, 6. 6 and 7 are connected through a resistor. That's this guy. Now 6 and 2 is connected together, so I'm going to connect those two together. Like that. So 6 and 2 are connected together. Now we have our capacitor. Let me grab my cap. This is the cap we're using, is that guy, so we can actually measure this out on our template. It's always nice to have the components around so you can do a quick measurement. So it looks like that will fit. So right here, here's our cap. You want to label these too. And that goes to ground. So here's our cap from 6 and 2 going to ground. Okay, we're almost done. We just need to bring pin 3 over to our LED, and we're finished with this side.